Hello everyone. Today I have a new question for you, and that is it possible to solve for an inverse dot product given certain conditions? And to start off, I am going to explain what the regular dot product is. So that would be A dot B equals the sum over all i's to the k n of the product of all the matching indices of A and B. So that would be like saying A1 times B1 plus A2 B2 plus so and so forth until you get to AN BN. Okay, so now let's put this into matrix form. So let's go back, let me come up with an example. So let's say we have 1, 2, 3 as a matrix and 4, 5, 6 as a matrix. And let me just label these, and this is matrix A, and this is matrix B. This will be important for later on. So this will equal 1 times 4 plus 2 times 5 plus 3 times 6. I'm running out of room, so let me just do down here. That will be 4 plus 10 plus 18, which is equal to 32. So, in matrix form, A dot B is equal to 32, and for this essential argument, let's call this number C. Okay, so let's make this matrix a little bit simpler, and I actually just said it. This will be A dot B equals C. Okay, so this is basically the concept of the dot product. Okay, so this is where my question comes into play. I have to erase all this. I don't have enough room. And I think the numbers in the A and B are easy enough to remember. So, again, we have A dot B equals C. Now, if we were to say this by saying, what if we knew A and we knew C, is it possible to find B? And if I wrote this in a matrix again, that will be this. 1, 2, 3, equals 32. And let's just call this x1, x2, x3. So if we wrote this algebraically, we would have x1 plus 2x2 plus 3x3 equals 32. So my question is, again, if we knew A and we knew C, is it possible to find x1, x2, and x3? Now again, this is just an example. There could be hundreds, even thousands of x's in this equation. So now when you look at this equation, if you know math pretty well, you can see that there should be an infinite amount of solutions given that, look at my pen, given that x and all the x's are real. However, in the I said given certain conditions. So the conditions that I'm giving here in my question is that S is not an element of the, or more specifically, S has to be an integer, and also all the values of A have to be unique, which means that they have to be different, and they cannot be a linear combination of each other. So this would be a really bad example because we can see here that 1 plus 2 is equal to 3. So that won't work in this example. So a better example would be, say, 1, 2, and 4. Because 1 plus 2 is 3, so you don't have a 3 here. And 2 plus 4 is 6, you don't have that. And 1 plus 4 is 5, and you don't have that. And another condition is that the value of C must be an element in the range of 0 or to the sum of all the values of A. Inclusive. So that means, and again, this is a bad example because the 32 is not fit in the range. So, if we use the 1, 2, 4 example, then C has to be between 0 and 1 plus 2 plus 4, which is 7. So, and the final condition is that all the values of the x's are either 0 or 1. So, let me write that here. Okay. So, I don't like that. Okay, so, again, my question is it possible to solve for the inverse dot product knowing A and C and finding B under the condition that all the values in A are unique and not a linear combination of any of the others? C has to be a value between 0 and the sum of the values of A, and the values of B are either 0 and 1. So, is it possible to find the B matrix or vector? So, again, thank you for watching, and this is what I'm currently working on. So, there should be a light to all.